Hello student, welcome to the lecture number 30 of Petrochemical Technology. Here the new topic is polymerization and isomerization. So this is the two different uh, types of reactions that happens into the petroleum refinery, and this is very important for petrochemical industry mostly. So let's talk about the polymerization. The polymerization and isomerization are two distinct processes in the field of chemistry, particularly in the realm of petrochemicals and organic chemistry. So each of its unique characteristics and outcome. So each process, the isomerization and polymerization, everyone have the different outcomes. So let's talk more detail about the polymerization. What is polymerization? Polymerization refers to a chemical process in which the small molecules called the monomers, say for example the single molecule of ethane or the propane or butane, like this. So this is called the monomers. The polymerization refers to the chemical process in which the small molecule called monomers join together to form large molecules known as polymers. So single molecule join together, like for example the ethane, n number of ethane are joining together, then it forms the ethylene. Similarly butane, butylene, propane, propylene. So into this reaction the small single molecule monomers join together to form a large chain of molecules. So this reaction can occur through various mechanisms such as addition polymerization and condensation polymerization. So polymerization reactions are basically happens with two types. One is addition polymerization and another is condensation polymerization. So let's talk about the addition polymerization. This type of polymerization involves the repeated addition of monomers after one, like this. So repeated addition of the monomers, the same type of monomers with unsaturated double or triple bond called vinyl monomers to form the long chain of polymer. So this means the addition polymer is involves the repeating addition of the monomers with unsaturated double or triple bond, that is called the vinyl monomers to form long chain of monomers. Example is include the polymerization of ethylene to form polyethylene. So once there is a polymerization of ethylene, it forms the polyethylene because ethylene has unsaturated double bond. Or the polymerization of styrene to produce polystyrene. So styrene, n numbers of polystyrenes are joining, then it is making a new product, that is polystyrene. So this is a polystyrene is basically a rubber, and polyethylene is your petrochemical plastic. Then next type of polymerization we have condensation polymerization. In this process the monomer react to form a polymer while producing small molecules like water, alcohol byproduct. So here into this process the monomers will react and to form polymers while producing a small molecules like water, alcohol, that is byproduct. So common example include the condensation polymerization of monomers like adipic acid, hexamethylene diamine to produce nylon, or the reaction of phenol with formaldehyde to form the phenolic resins. So this is the example of the condensation polymer. So in the condensation polymers, the monomers will react to form the polymer while producing small molecules. They are not producing the big molecules like in addition polymer, like water or alcohol or byproduct. So these are the different byproduct of the condensation polymers. We are producing the water or alcohol, that is byproduct into the condensation polymer. The example of the condensation polymer is the polymerization of monomers like adipic acid and hexamethylene diamine. If these two are in undergoing a condensation polymer reaction, they are producing nylon, or reaction of phenol and formaldehyde to form phenolic resin. So this is the example of the condensation polymers. The first example is the reaction between the adipic acid and hexamethylene diamine to produce nylon. So nylon is being produced by the condensation polymer, that is with the help of adipic acid and hexamethylene diamine. And the another example of this reaction is phenol and formaldehyde. These two are reacting and they are producing the another type of polymer, that is phenolic resin. So this is the example of the condensation polymer. Now polymerization is widely used in the production of plastics, rubbers, fibers and various synthetic material, essentially in everyday product and industrial applications. Now the isomerization. We will talk about the isomerization. So what is isomerization? Isomerization is a chemical process that involves rearranging the atoms within the molecule to form structural isomers. So into the same molecule, the structure is rearranged. Their position is changed. So once their position is changed, it forms a new molecule, sorry, new product. So isomerization is a chemical process that involves the rearranging the atoms within the molecule. It is not changing the structure. It is not increasing the number of molecules, but within the same range of number of molecules, the rearrangement of rearrangement of the molecule is happening where a new product is being formed. So in isomerization, it is a chemical process that involves rearranging the atom within a molecule to form structural isomers compound with the same molecular formula but different structural arrangement. This compound will have the same molecular formula, but the arrangement of the crystal will be different, or there will be different spatial orientation of the crystal. The hydrocarbon isomerization. In the context of hydrocarbons, the isomerization often refers to the rearrangement of the hydrocarbon molecule to form the isomers with different arrangement, but the with the same molecular formula. For example, the isomerization of a straight chain alkane into branch chain alkane, or another example is conversion of cis to trans isomer in alkanes. Now the catalytic isomerization. So what is catalytic isomerization? We will come to know about more detail. The catalytic isomerization refers to the isomerization reactions catalyzed by specific catalyst under controlled condition. For example, the isomerization of normal butane to isobutane using the catalyst like platinum or supported metal crystals. So this is in presence of the catalyst. That catalyst is platinum or metal catalyst. So the catalytic isomerization is basically isomerization process that happens in presence of the catalyst. So isomerization process are essential in petroleum industry for enhancing the quality of the fuel, such as converting less desirable straight chain hydrocarbon into more desirable branch chain isomers with improved combustion characteristic, octane rating and stability. And both isomerization and polymerization play a crucial role in various industries, contributing to production of wide range of material and enhancement of chemical properties into the hydrocarbon and other compounds for their practical applications. This is a systematic polymerization process, a picture that is shown into this slide. You can see we have a propane and butane. These are the olefins, oleophilic feed. It is this feed is going into the drum. So from here this reaction takes place and it comes to the quench tower. After coming to the quench tower, this is being this is further going to a flash turret, which is under the recycling stage. Then after the recycling stage, it is going to a stabilizer where we are getting a polygasoline. This is a polymerization process of gasoline, and here the again we are recovering the propane and butane. So next topic will be continued in lecture number 31. So if you have any query or question, you can write to me. Thank you.